Good morning everybody, hope you're all healthy and safe. Let us continue with our section 2.1, solution curves without a solution. In today's lecture we shall be discussing about the concept of a new type of differential equation. We have already learned different types of differential equation like linear, non-linear, then based on the order what will be a differential equation, based on the type and so on. So now we shall be concentrating on the concept of autonomous differential equation. Okay, so this is mainly focused on first order differential equation. So an ordinary differential equation in which the independent variable does not appear explicitly is said to be autonomous. So you can see an autonomous first order differential equation, it can be written, the general form is f of y comma y dash is 0 or dy by dx is equal to f of y. That is, if we are considering x to be the independent variable and y to be the one which is dependent on x, then that differential equation will not contain a term of x explicitly. Okay, that is, if you consider, I'll tell you the example. If you consider dy by dx is equal to y square plus y, that is an autonomous first order differential equation. But if you consider dy by dx is equal to xy plus 2, that is not autonomous. That is, x is appearing elsewhere explicitly, then we don't call that type of differential equation to be autonomous. So in an autonomous differential equation, the function that we are considering, that dy by dx equal to some function, that will be exclusively in terms of only y. That is called as the autonomous first order differential equation. So this comes in use when we are like focusing on, we have seen in section 1.3 many applications. So on all those things, mostly we are considering things to be dependent on time and all. So, and you can see that the corresponding equation or differential equations that we have formed will have only the dependent variable, and it will not contain any independent variable explicitly. So that is the case. That is why we are bringing about this term autonomous differential equation. Now next is a concept called as critical points. This is related to autonomous differential equation. A real number c is a critical point of the autonomous differential equation if it is a 0 of f. That is, we had considered the general form to be dy by dx is equal to f of y. So if f of c is 0, we say that c is a critical point. Okay, this critical point is also sometimes called as the equilibrium point or the stationary point. So a constant solution y of x equal to c is called an equilibrium solution. Okay, so the equilibrium point or the critical point is that point at which the function f becomes 0. Okay, that is the critical point. Now if we consider the solution y of x equal to c, that solution, such a constant solution if it exists, is called as an equilibrium solution. And note, the c is just not a constant, it is the critical point corresponding to the given function. So so if you have if we consider y to be this constant, that is the critical point, then what will be dy by dx? It will be 0, and on the right hand side we have f of c is 0, so that will definitely be a solution. Okay, so if you consider the critical point, I hope you are getting the picture. We have the function or the differential equation dy by dx is equal to f of y, and if c is a critical point, f of c is 0. So one side becomes 0 and the other side is dy by dx. And if we consider the solution to be y equilibrium solution, that is y is equal to c. That is, y is again a constant, so derivative is also 0. So that is actually, this equation is actually a solution of the given differential equation, and it is called as equilibrium solution. So let us see one example which is given in your textbook related to the critical point and stuff. And here we have example 3. The differential equation is given as dp by dt is equal to p into a minus b into p. So here you can see that the independent variable is t, okay, and the dependent variable is p. Okay, and you can note that on the right hand side there is no expression in terms of t. So this is an autonomous differential equation. Okay, so here what will be f of p? F of p will be p into a minus b into p. F of p will be p into a minus bp. Okay, so we'll have to find the critical points. Now how can we find the critical points? By just putting f of p equal to 0. Okay, so when I put p into a minus b into p equal to 0, what do I get? I get either p is 0, or from this solving I'll get p is equal to a by b. So these are the two values at which the function f of p becomes 0. So the critical points are 0 and a by b. So I hope you are clear. Okay, and what will be the equilibrium solution? Equilibrium solution will be p of t is equal to 0 and p of t is equal to a by b. That is, they will be equal to the critical point that we have determined. So this type of questions can be asked to determine the critical point of the given autonomous differential equation. So it's easy. We just have to put the function equal to 0 and find the corresponding points. And to determine the equilibrium solution, we just have to put p of t, or that particular function solution independent variable of x. I'm sorry, the independent variable corresponding to the dependent variable corresponding to the independent variable will be treated as a function, and that should be equal to the critical points. Okay, now there is one more thing that is introduced here, that is, if you consider p of t is equal to 0 and p of t equal to a by b as a critical point, we are going to divide the line. Okay, we are going to consider a vertical line. Okay, you can see figure 2.1.4. This is a vertical line, and we can divide this into three parts. That is, one is at 0 and the other is at a by b. Okay, now if you consider the interval minus infinity to 0, then you can see that the function is negative over there. Okay, I mean the function value is negative, and so p of t will be decreasing. So there we will put the point, we'll put it downwards. Now in the next interval 0 to a by b, the sign, if you take any point in between 0 and a by b, and if you substitute in this f of p, you'll always get a positive value. So f of p is positive. So if f of p is positive, correspondingly our function will be increasing. Okay, so if it is increasing, then we'll put an arrow upward. And the other case, the last one is a by b to infinity, again you will get minus sign, and it will be decreasing and it points downwards. So this will be the figure, and this type of figure is called as the one-dimensional face portrait, or simply just a face portrait. And a face line is just a definition and something that you have to keep in mind if at all we can be asked in the part A or part B portion in the examination. So once we get the critical points, we can draw the corresponding face portrait. How is it? We just have to draw a vertical line, and we have to see if we have, this is the case of two critical points. If you have more, correspondingly you have to divide it, and you have to consider the intervals and see whether the function f of p becomes negative or it is plus or is it positive, and correspondingly if it is negative, then the p of t will be decreasing, and correspondingly if it is positive, it will be increasing, and if it is increasing, we'll put an arrow upward, and if it is decreasing, we'll put an arrow downward. So this is called as a face portrait, and the vertical line is known as a face line. Okay, so that is what we are discussing today about the autonomous differential equation and the corresponding critical point, and the example in which we have seen the concept of face portrait and the face line. So that's it for today's session. Thank you.